Good evening, and welcome to today's Voyager mission. We are approximately 15 minutes from liftoff. Today's mission will demonstrate the Voyager 9's launch vehicle carrying a special cargo into high Earth orbit. At this point, both stages are nearly fully loaded with propellant. The launch vehicle is completing final guidance, navigation, and control checks, while our teams monitor thousands of telemetry points. This mission will be a test mission for our Voyager 9 rocket. It is approximately 200 feet in height, 30 feet in diameter, and has two stages. A primary booster that will come back and hopefully land right next to our launch pad, and a second stage that will carry the rocket up into orbit and later disconnect and fall back into the sea. Our payload, as stated, is a special vehicle that our crew has been working on for many months. It is carrying one of our Voyager Roadsters. Today our weather is nominal, and this is going to eliminate the possibility of a scrub of today's launch. Our launch site is currently the Kraken in 39A launch pad, which we have used for the past several years. Good evening, and welcome to the Voyager Flight 1 launch broadcast. I'm Parker, coming to you live as we prepare for the first orbital flight of the Voyager 9 launch vehicle. Today marks an important milestone for Voyager 9. After years of design, engineering, manufacturing, and testing, this vehicle is now preparing to attempt its first journey beyond Earth's atmosphere. This mission today is a demonstration flight. The primary objective is to gather data, test vehicle systems, and prove out the technologies needed for future Voyager X missions. Over the next several hours, we'll be following every major milestone, from final countdown operations to liftoff, ascent, stage separation, recovery operations, and payload deployment. In front of me, on the pad, is the Voyager 9 launch vehicle. Standing at approximately 70 meters tall, this two-stage rocket is designed around one major goal: reliable and reuse access to orbit. The first stage, known as the booster, provides the majority of the energy needed to leave our atmosphere. After completing its job, the booster will separate from the upper stage and attempt a controlled return to Earth. The second stage will continue carrying the Pathfinder 1 spacecraft into orbit before deploying the payload. Before we get into today's countdown, let's talk about what this mission is designed to accomplish. The first flight is about learning. Every sensor, every camera, and every measurement collected during today's mission will help engineers improve future vehicles. During the flight, the vehicle will be continuously sending information back to our mission control. Engineers will monitor engine performance, temperatures, pressure, guidance systems, navigation data, and hundreds of other parameters. Our mission will consist of liftoff at approximately 7:30 p.m. Central Time. Our vehicle will lift from the pad. At approximately T plus 1 minute, we will begin our pitch program / ascent. At 2 minutes 30 seconds T plus, the rocket will face maximum aerodynamic pressure. At approximately T plus 3 minutes, we will see booster separation. At approximately 8 minutes, we will see our booster landing. And approximately 35 minutes after launch, we will see the payload deployment. We are currently inside the final hour before launch. At this point in the countdown, teams are focused on final verification of the vehicle and ground systems. The launch team has already completed many critical operations, including vehicle inspections, communication checks, and flight computer activation. Inside Mission Control, dozens of engineers are monitoring different parts of the mission. Each console has a specific responsibility. Some teams monitor propulsion systems, others focus on guidance, navigation, recovery, communications, and flight safety. A launch like this is not controlled by one person. It is a coordinated effort between hundreds of people working together across the entire mission. The vehicle is currently preparing for final propellant operations. Voyager 9 uses cryogenic propellants, which means they must be maintained at extremely low temperatures before launch. These fuels provide extremely high performance, allowing the rocket to generate the massive amount of energy required to reach orbit. You may notice the white clouds surrounding the vehicle during the countdown. This is normal. Those clouds are caused by condensation forming around the extremely cold fuel tanks and plumbing it. It is not smoke from the rocket. Weather is currently green for today's launch attempt. Launch weather is more complicated than simply looking outside and seeing clear skies. Teams monitor everything from surface winds to our upper atmospheric conditions because the rocket will travel through many different environments during ascent. The vehicle must also have safe conditions along its flight path. Range safety teams are responsible for monitoring the area around the launch corridor and making sure the mission can proceed safely. We are now approaching halfway from liftoff. The countdown is moving towards the final terminal phase, where the vehicle will transition from We are now approaching 5 minutes from liftoff. The countdown is moving towards the final terminal phase, where the vehicle will transition from ground-controlled operations into autonomous launch mode. During launch, the rocket's onboard computers will constantly make adjustments. A rocket is not simply pointed upward and fired. The vehicle is actively controlling itself through thousands of times per second, adjusting its engines and flight paths to stay on course. For anyone watching a rocket launch for the first time, one of the most important things to understand is that spaceflight is mostly about speed. Reaching space is relatively easy compared to reaching orbit. To stay in orbit around Earth, a spacecraft must move sideways fast enough that while it's falling towards Earth, the planet curves away beneath it. That balance between gravity and velocity is what creates our orbit. Voyager 9, proceed with terminal countdown preparations. You just heard the flight director authorize the team to begin terminal countdown preparations. From this point forward, every system moves towards its final launch configuration. 4.5 minutes remain before liftoff. The vehicle is now approaching the final moments before launch. For the engineers and technicians who have worked on Voyager 9, this is a moment where years of hard work come down to a few minutes. The rocket standing on the pad represents the thousands of individuals working together. Engines, computers, tanks, valves, communication systems, and guidance hardware all have to work perfectly. The launch team is now completing final checks before liftoff. You will now hear the final go no-go poll for today's launch. Guidance ready. Guidance is ready. Propulsion is ready. Ground systems ready. Range ready. Recovery ready. All major systems are reporting ready at this time. We are at T-minus 3 minutes. The vehicle is now fully configured for flight. The countdown is now controlled by the onboard computers, which will handle the final sequence leading to ignition. 1 minute remaining. Voyager 9 Flight 1 is moments away from beginning its first orbital mission. The Voyager 9 vehicle is now in startup. "30 seconds. 20 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Lift off. Go Falcon. Go Falcon. Liftoff of Voyager 9 Flight 1. The first Voyager X vehicle has cleared the launch tower and is beginning its climb into the sky. The engines are firing at full power, generating the thrust needed to carry this vehicle away from Earth. Voyager Flight 1 is officially underway. Ladies and gentlemen, we have lost contact with the vehicle. We still have coverage of the first stage booster. We will wait for the booster to return and attempt to land. Thank you for tuning into this live stream.